Climate change is real, and our personal gas vehicles are a big contributor to the carbon emissions released every day. Something we can do to combat this is work towards solar-powered vehicles. We are Group 15, Papaya, one of the major players in the automobile industry. We need to make the winning car for the biggest event of the year, the ME229 drag race. We will design an operational solar panel model car that costs less than $25, limits usage of embodied emissions, and is as fast and aesthetic as possible. We started out with some research to figure out how we could implement all of our objectives into our design. Our key findings were that focusing on higher solar panel current will provide more torque, the correct gear ratio is vital to obtaining max possible speed, and the easiest way to increase speed is to make the car lighter. Once we knew the key project requirements, we started brainstorming some alternatives. We came up with 4 options that would be able to meet our goals. Our top contenders were the Cage Menace, which has a very lightweight and unique chassis, the Hot Rod, which aims to realistically imitate actual cars, the Speedy Shoebox, which focuses on simplicity, and lastly, we have the Trickster Trike, which uses 3 wheels and a more aerodynamic frame. After running their objectives through a weighted decision matrix, we decided that the Trickster Trike would be the best option, but we wanted to blend it with the Hot Rod so that the engine was at the front. This led to our final design, the Quick Comet. The best part about it is that it has a spoiler.
After creating all of the working drawings, we laser cut the parts into birch wood. We glued the parts together but quickly realized that our design was too heavy and didn't have the right spacing. So we went back to the drawing board and made a completely new design, the Swagon Wagon. It has a 3-volt solar panel, a 4800 revolutions per minute motor, and 16 individual pieces of birch wood. We cut out a lot more of the extra wood to keep it light and made sure to consider available space for the motor and the solar panel on the body. Now that we had our prototype made, we had to test it to see if it was actually going to be the winner of the race and how we could improve it if it had any weaknesses. Luckily, we noticed right away that our car passed the finish line even without the solar panel. So now all we had to do was focus on speed. Once the solar panel was installed, we tested it for optimum light positions and how various different materials affected the traction on the wheels. We tested plain wood, electrical tape, balloons and rubber bands, and found that balloons made our car go the fastest at an average of 0.85 seconds to finish the meter-long track. With our balloons in place, the Swagon Wagon was ready to finally win races for us. All of this designing, planning, testing and fabrication led up to the day we have all been waiting for, race day. On the race day, we faced a challenging group of competitors and ended up getting knocked out in the semifinals. In the end, Papaya was successful in creating a solar-powered model car that will hopefully drive the industry towards more solar-powered vehicles in the future so that we can all decrease our carbon emissions and save our planet.